Hi, I'm Alexandra Maybe Hoya from ECE31 of De La Salle University Dasmariñas, and this is Summative 1 of our Power Electronics Lab subject. The Summative Assessment 1 for our midterm in Power Electronics lecture and lab, we are asked to use PSpice to determine the instantaneous and average power in the given problems below. We are asked to submit the recorded video with the explanations in the SB Dropbox. So the problem is, a current of 5 sine 2 pi 60 Ta enters an element. Sketch the instantaneous power and determine the average power absorbed by the load element when the element is a 5 ohm resistor, a 5 millihenry inductor, and a 12-volt source current into the positive terminal. So to do this, the first step is, of course, we have to open the ORCAD application. Click ORCAD. Wait for the application to run. Once the ORCAD app is open, click New Project. Write the name of your project, Summative 1, and make sure that analog or mixed is toggled, and then click Create a New Blank Project. Click OK, and then wait for the application to load. And now we are about to place a 5 ohm resistor, letter A. So to do that, click Place, PSpice component, Source, Current Source, and Sign. And then we should place it in our page 1. And then after this, we will add now the resistor, place, PSpice component, resistor, let's rotate it. And then we should also place a ground. And now it's time for us to wire it. So let's wire these in series and then connect the ground to the circuit. After this, we should change the values of the resistors and the source. The I off is 0, the amplitude is 5, and the frequency is 60. Okay, and then after this, should now click on New Simulation Profile, and then name it Sum A or anything you want, and then click Create. After that, a pop-up window should appear, and then here we can change the runtime to 0.01667 seconds or 16.67 milliseconds, and then click Apply and OK. And then it's time for us to run the simulation. Click Play, and then a pop-up window should appear again. And now we can add the traces. We should click here, Add Trace, and type to get the instantaneous and average power, which are W times R1 space the average AVG times W times R1. After this, we click OK, and then as you can see here, the green waveform is the instantaneous power, and the red waveform is the average power of the circuit with a 5 ohm resistor. To check the values, right-click, cursor on, and place here at the peak. And as you can see here at the table below, the value is, and as we move the cursor, the green one, you can observe that the peak value is 124.929 watts, and the average for the red is 62.939 watts. So putting these values in comparison with the calculated values, it can be observed that they are somehow very close to each other. So the solution for the calculated values in the 5 ohm resistor, here the resistor is 5 ohms and the current is 5 sine 2 pi 60 Ta. And if we are to check, the instantaneous value of the power and the average value of the power. The first step is to calculate the voltage across R with the formula VR is equal to IR. And substituting the formula, we're going to get 25 sine 2 pi 60t volts. And for the instantaneous power, to get that, P instantaneous is equal to VR times IT. And substituting again the values, get an instantaneous power of 125 sine squared 22 pi 60 watts. And for the average power, the formula is P average equals 1 over T, 0 to T P T dt, and substituting the values for the run time that we used, 16.67 milliseconds, and, and if we are to get the half angle, we are to substitute these. And after computing, we're going to get 61.41 watts. Letter B, we are now to change the component to a 10 millihenry inductor. So we're going to do is we're going to go to ORCAD and delete this resistor and change it with a inductor. So we're going to click place, piecewise component, and an inductor. Rotate it, and I'm just going to change this to 10 millihenry and click OK. And then we could rewire it. I'm just going to delete this and wire this here and here. And then after that, we should create a new simulation profile, sum B, and I'm going to click create, and then a pop-up menu should appear and change it again to 0.01667. Click apply and then OK. And then we are to run it. After we run, a pop-up menu should appear, and then we should add traces. So for us to check the instantaneous and the average power, we are going to type W times L1 and average of W times L1. It's important to place a space in between and then click OK. Then as you can see here, the green waveform is the instantaneous power and the red waveform is the average power. If we are to check the peak value of the instantaneous power, we are going to place the cursor here, and as you can see, it recorded a value of 47.173 watts. And for the average, we're just going to change the cursor for the average waveform there, and we're going to place it at the very last of the waveform. And as you can see, it recorded a value of 0.0607 watts. To check the peak to peak, we're just going to place a negative sign in the formula W times L1. And as you can see, this blue waveform here, if we put on the cursor from the positive cycle's peak and the negative cycle's peak, it can be observed that okay, and then here, there, it can be observed that the peak-to-peak voltage is equal to 93.743 watts. If you are to compare the measured values with the calculated, it can be observed that they are very close to one another. For the calculated values, this is how we got the answer with a 10 millihenry inductor. The instantaneous power is the formula of P. Instantaneous equals VL times I. Substituting the values to the formula, we will get final answer of for the instantaneous power of 94.24 sine squared 2 pi 60t. And for the double angle, the formula sine squared theta equals 2 sine theta cosine theta. Again, substituting the values, we are to get 47.12 sine 2 pi 60t cosine 2 pi 60. And for the average power, this is the formula. P average equals 1 over t to 0 to t p times dt, and integrating it with and substituting the values for the time stop, which is 16.67 milliseconds, and using this trigonometric identity. And when we solve this and compute for the values, we're going to get average power that is very close to 0 watts. And now when we are to connect a 12 volt DC power source, what we're going to do is open ORCAD and just click this inductor and just change it to the 12 volt DC power source. So we're going to place voltage DC and connect it to the positive terminal, and then connect this wire. After that, we're going to change the value of this. Let me just close this. This DC source to 12 volts. And then after that, we're good to go for a new simulation and some C. Okay, and then when we change this again to 0.01667, and then click apply, and then OK. After that, we're good to go to run the simulation, and we're going to click run, and then this window should pop up, and we're good to add traces. So we're going to add trace, and for the instantaneous power, W times V1 for the voltage source, and for the average power, AVG times W times the average of the voltages. And as you can see, just as the same as before, the green waveform is for the instantaneous power, and the red waveform is for the average power. The instantaneous power for the 12 volt DC source shows a value of 59.984 watts, and checking the average power, okay, here you can see a value of 0.001 watts, which is very close to 0 watts. In this table, you can be observed that the values for the measured and calculated values are very close to one another in a 12 volt DC source. The calculated values from the previous table was obtained using this formula. For the instantaneous power, P instantaneous equals VTC times I. Substituting the values, we are going to get 60 sine 2 pi 60 watts. And for the average current, so we can get the average voltage. This is the formula. And substituting values again, we are to get 299.94, and we're to multiply it to 0. The current is 0. And so we can solve for the power, since the formula for power is this, P equals VI, and substituting the values, we're going to get 0 watts. And that's all for the simulations. In conclusion, it can be concluded that using the application ORCAD and PSpice, the instantaneous power and average power for the given source in the problem was obtained. It was observed from the comparison of the results per component, mainly the 5 ohm resistor, 10 millihenries inductor, and the 12 volt DC source, that there are big differences in their power. For a 5 ohm resistor, the instantaneous and average power are very high, with a value of 124.829 watts and 62.939 watts. Meanwhile, for the 10 millihenry inductor, it was observed that it had the smallest power wattage compared to the resistor and voltage source, with a value of only 47.173 watts and 0 watts. Lastly, for the 12 volt DC source, the measured wattage showed 59.984 watts and 0 watts. All measured data are very close to the calculated values. For the recommendations, these observations could be understood when one has knowledge in ORCAD and PSpice app, its simulation procedures, and the interpretation of the data gathered. Also, it is essential to understand the integration and the Ohm's law. to understand the relationship of the components in the circuit and to prove if the gathered data is accurate to the calculated values.